This is a slightly longer example, but uses the same few formulas of projection and length of projection. So if you're given, you can see the position vector of A, B, C are given. This I generally like to write the position vectors in column vectors form. Later I will show you. Then they ask you to find the projection of BA on BC. First, we find part 1, projection of BA on BC. I don't think it's difficult, but before that, let us again recall this one in the bottom right hand corner. You can see this. Always have it in your mind how to these three formula. What is the projection formula of one vector on another vector? So basically, you do want to find what is BA, what is BC, and you actually know what is OA, OB, OC, and it's not difficult to find BA from this here. All right, so I don't think I want to spend too much time. You can easily get here. BA is OA minus OB, BC is OC minus OB. So essentially what you want to project this on this. If you can call this A, if you call this B, in I loosely speak here, all right, then you are actually applying this formula over here. All right, you want to project BA on BC. So now projection of BA on BC is BA prime. Now if you take a look at my diagram here, I draw it like that, where BA is this way and BC is the other way, where the angle between BA and BC is an obtuse angle. Actually, I do not know. I do not know. Before any calculation, I do not know. If you had drawn BA like that and BC like that, this is perfectly fine too. The reason why I'll explain why I draw it in this way later. But if you had drawn it this way, which I would recommend that you draw a diagram, nobody will fault you. Nobody will fault you. Now, so BA on BC, we call it BA. This is BA prime. The objective is to find BA prime. Now, applying the formula, you would have gotten this. Right? You have gotten this, and you will get this answer. I just want to highlight this part here. After you dot product here, this one, you actually get negative 2 over root 3. So the only reason why this diagram is shown to you in this example, whereby this is an obtuse angle, is because there is a negative here. After you dot, you realize there is a negative sign. It actually just means that the angle between BA and BC is an obtuse angle. All right, that's it. All right, that's the only reason. But again, I say, if you had drawn it this way, you will not be penalized. Don't worry. We just want to be correct. We draw a diagram as such. All right. Okay, so that's done with the first part. The second part, you want to find the component of BA that is perpendicular to BC. Now, if I can draw the diagram again, all right, this is BA, and we now know that this is BC. All right, you want to find the component of BA that is perpendicular to BC. Essentially, you want this component. You want this component. Just now, you have already found BA prime. All right, this is found BA prime in part 1. You want essentially to find, let's go back to here. This, I would always like to put this in the corner here to remind ourselves. Now, so the diagram here, actually what do you want? This BA prime is actually known. This one is actually known. What you want is this one. Right? What you want is actually this, which is A prime A. So if you see, this vector can be resolved into two components. This vector can be resolved in two components. The component that is parallel to BC, and the component that's perpendicular to BC, which is what we want. So in this case, we want A prime A. which if you can see here from the bottom right hand corner, all right, to find the vector that is perpendicular, there's no shortcut. All you have to do is to use vector addition or subtraction to say that it's BA minus BA prime, and then BA is found, BA prime was found. This one is found in part 1. BA prime is the one answer in part 1. Then you can get the answer. Next, the question asks us, part 3, the question asks us to find the least distance from A to the line passing through BC. Let us recall, this is your C somewhere here, right? From earlier. Okay, this is your C, because essentially BA prime is the projection. BA prime is the projection of BA on BC. So the question asks us the least distance from A to BC, the line passing through BC. Actually, they just want you to find this distance, this length here. But take note, this is not the length of projection, yeah? This is not length of projection. The length of projection is here. You're actually finding this one. You want the least distance from A to BC actually is the length AA prime. All right, which not difficult. I already found AA prime. Just find the magnitude of the vector. Then I get this. All right, that's that.